Have you ever, got your hands on some amazing new tech, maybe something that feels almost like magic, but then you struggle to get it to do exactly what you pictured? You sense the power is there, but actually unlocking it feels a bit like fumbling in the dark sometimes. Well, today we're doing a deep dive right into that challenge, but specifically focusing on GPT-5. We're going way beyond just asking it simple questions. Our mission really is to arm you with the expert prompting techniques needed to truly harness its capabilities. We want to show you how to shape its outputs so they're efficient, smart, and perfectly suited to what you need, whether that's building complex AI agents or crafting flawless code. We've been digging through the official guides, insights from real-world use, and even specific examples from, the big AI players who've been testing GPT-5. So get ready for some hopefully real aha moments today. Okay, let's get into it. The documentation calls GPT-5 a substantial leap forward, big words, especially in areas like agent tasks, coding, general smarts, and steerability. What does that actually mean for someone trying to build with this thing? And why is prompting suddenly even more critical?
Well, it's fascinating because while GPT-5 is, yeah, incredibly capable right out of the gate, the guide really hammers home this point. To truly maximize the quality you get out of it, prompting isn't just a simple command. It absolutely requires experimentation. Think of it less like typing into a console and more like, I don't know, tuning a really sensitive instrument. The specific way you phrase things can drastically change the result. It's not one size fits all. And for developers, especially if you're building agentic flows, these AI systems that handle multi-step tasks on their own, there's a core recommendation. Use the responses API. The big advantage here, the key insight, is that the model's reasoning, its kind of internal thought process, is persisted between tool calls. It remembers why it did something.
So it doesn't have to figure things out from scratch every single time. It needs to, say, use a tool.
Exactly. It avoids that whole rethink everything loop. This leads to, well, significantly more efficient and frankly more intelligent outputs. Your agents become more robust, less likely to get lost or, forget what they were doing halfway through.
That ability to remember its reasoning, that sounds powerful. But it brings up that classic AI challenge, doesn't it? How much rope do you give it? How do you control its eagerness? How proactive should it be versus just waiting for instructions? They say GPT-5 can operate anywhere on that spectrum. How do we actually control that?
Yeah, this is a really crucial control knob. If you want less eagerness, maybe for a more cautious agent, or to cut down on exploration depth and improve speed, improve latency, you can start by lowering a parameter called reasoning effort. Think of reasoning effort like a dial for how much internal thinking the model does before acting. And interestingly, the guide notes that a lot of tasks can actually get done perfectly well with consistent results at medium or even low reasoning effort. That's a potentially huge win for efficiency.
Okay, so lower reasoning effort for less proactivity. What else? Just that parameter.
No, it's more than that. You also need to be really explicit in your prompt about how it should explore the problem space. The guide gives this context-gathering template with some very direct instructions. Things like get enough context fast, parallelize discovery, and stop as soon as you can act, or even avoid over-searching for context. You're giving it rules for its information gathering.
So you're kind of setting boundaries on its curiosity.
Exactly. You can even set hard limits, like fixed tool call budget, say, or absolute maximum of 2 tool calls. And crucially, you need an escape hatch. Something like adding, even if it might not be fully correct, allows it to move forward when it's uncertain. It makes the model more pragmatic. It can proceed even if the data isn't perfect, which, let's face it, is how the real world works most of the time.
Right, pragmatic. Okay, that covers dialing it down. But what if you need the opposite? What if you're building something where you want that high degree of autonomy? You want it to push through problems. Is there a danger it goes too far?
For sure. If you want more eagerness, you'd obviously start by increasing that reasoning effort parameter. And then you lean heavily on something like the persistence prompt template. This template includes some really strong directives, things like, you are an agent, please keep going until the user's query is completely resolved. Or never stop or hand back to the user when you encounter uncertainty research, or deduce the most reasonable approach and continue. And even do not ask the human to confirm or clarify assumptions. It really pushes the model to be proactive.
Wow, okay. That sounds powerful, but also slightly scary. How do you put guardrails on that?
That's exactly it. Guardrails are essential. You absolutely have to clearly state the stop conditions for its tasks. And critically, define what counts as safe versus unsafe actions for the tools it might use. For instance, the guide suggests that tools for things like checkout or payment should have a really low uncertainty threshold, meaning if it's not sure, it must ask the user. whereas a simple search tool can have a much higher threshold, allowing it to proceed more freely. It's about tailoring the risk profile to the action.
That makes a lot of sense, setting different safety levels for different actions. Okay, so beyond just controlling how eager it is, what about transparency? If it's doing all this complex work, how do we make sure the user knows what's going on?
Yeah, good point. This is where tool preamble messages are really helpful. GPT-5 is actually trained to give clear upfront plans and regular progress updates. This makes the whole interaction feel much smoother, especially for longer tasks. And your prompts can guide the frequency, the style, even the content of these updates. The guide has a tool preambles example suggesting things like always begin by rephrasing the user's goal, then outline a structured plan and narrate each step succinctly. It really helps build trust. The user isn't just watching a black box, they see the plan and how it's unfolding.
Keeping the user in the loop. Got it.
And just circling back quickly to that responses API we talked about earlier, the performance gains are real. The guide mentions seeing statistically significant improvements in benchmark evaluations, like Talbench retail scores jumping from about 74% to over 78%.
That does sound like a noticeable jump in that kind of benchmark.
It is, and that improvement came just from switching to the API and including the previous response side. As we discussed, this lets the model access its past reasoning, its chain of thought, or CoT tokens. It conserves those reasoning tokens and, crucially, means it doesn't have to rebuild its plan from scratch every single time it uses a tool. That helps both speed, the latency, and the overall quality of the outcome.
Okay, super interesting for agent building. Now, let's shift gears a bit. A lot of people listening are probably developers using AI for coding. The guide makes some bold claims here, too, saying GPT-5 leads all frontier models in coding capabilities. What are its big strengths in that area?
It really does seem to be a powerhouse for coding. The documentation highlights its ability to work effectively within large existing code bases. It can fix bugs, handle complex changes, large diffs, and even implement significant refactors across multiple files or add big new features. And it's not just about working with existing code. It apparently also excels at creating new apps completely from scratch, handling both the front-end user interface and the back-end logic. It's kind of like having a very capable, context-aware pair programmer.
A pair programmer that understands the whole project.
Nice. And for the front-end side specifically, it's noted to have excellent baseline aesthetic taste, which is, frankly, quite remarkable for an AI.
So it makes things look good by default.
Apparently so, to a degree. And to get the best results visually, the guide recommends using modern, popular frameworks and libraries. Things like Next.js with TypeScript, React, Tailwind CSS for styling, Shatsnui for components, material symbols for icons, and motion for animations. These are all very structured, component-based tools, and GPT-5 seems to really understand how to work well with them.
Okay, so using the right tech stack helps. But say you're building something brand new, 0 to 1, or you need GPT-5's code to perfectly match the style of your existing, maybe quirky code base. How do you guide it to meet those specific standards?
Two slightly different challenges there. For the 0 to 1 app generation, an interesting technique testers found useful was creating self-constructed excellence rubrics. They used a self-reflection template to prompt the model to first think deeply about what constitutes a truly world-class single-page web app, considering all the different aspects, and then build it according to that internal rubric. It's like getting the AI to define excellent before it starts the work.
So it sets its own quality bar first.
Interesting.
And for fitting into existing code?
For matching existing code-based standards, GPT-5 is already pretty good at searching the provided code for context cues. But you can significantly enhance this. The trick is to use prompt directions that explicitly summarize key aspects of your specific code base. Things like your engineering principles, maybe your directory structure, common patterns, best practices. The coding rules template is designed for exactly this, helping the AI blend its contributions seamlessly with your team's style.
It really is like onboarding a new developer, just much faster. Okay, this reminds me, I read that the AI code editor, Cursor, was an alpha tester. They must have learned a ton about tuning prompts for GPT-5 in a real-world coding context. What were their big takeaways?
Oh yeah, Cursor's experience is super insightful. It really shows the iterative process. So initially they ran into this weird paradox. GPT-5 was giving these very verbose status updates about the code it was writing, which kind of got in the way. But the code itself was sometimes too terse, using things like single-letter variable names, making it hard for humans to read.
Huh. Verbose chat, terse code. How'd they fix that?
Their solution was clever. They set an API parameter, verbosity to low, specifically for the text outputs, the chatty parts. But then in the prompt itself, they strongly requested verbose outputs only within the coding tools. So concise updates, but well-commented, readable code. It shows you might need different strategies for different types of output from the same model.
Smart. What else did they find?
They also noticed the model could be a bit too hesitant, sometimes deferring back to the user when it probably could have just made the change.
Yeah.
This created unnecessary friction, slowing things down. So they added more product behavior details into their prompt, basically giving the model permission to be more proactive with code edits. They included lines like, your code edits can be quite proactive, as the user can always reject them later, and proactively attempt the plan and then ask the user if they want to accept the implemented changes. This made the whole workflow much smoother for developers using Cursor.
Giving it more confidence, essentially.
Exactly. And crucially, they discovered that some prompts that worked well with older models were actually counterproductive with GPT-5. For example, a prompt like maximize context understanding caused GPT-5 to overuse its tools.
How so?
Because GPT-5 already does a lot of internal reasoning and context gathering naturally. That old prompt pushed it too far, making it constantly reach for external tools, like search, even when it likely already knew the answer. It highlights how much more advanced GPT-5's internal thinking is.
So the old prompts were making it second-guess itself?
Sort of, yeah.
Yeah.
They fixed it by simply removing that maximize prefix and using softer language. This led to much better decisions by the model about when to rely on its internal knowledge versus when it actually needed to use a tool. It's a subtle change, but it shows you need to adapt your prompting style to the model's improved capabilities. Less can be more sometimes.
Fascinating. Less hand-holding needed, in a way.
Precisely. Oh, and they also found that using structured XML specifications, like wrapping instructions in tags like instruction spec, significantly improved how well the model followed those specific instructions.
XML tags for clarity. Okay. It really sounds like GPT-5 operates with incredible precision then. That surgical precision sounds amazing, but isn't that also a potential trap? If your instructions aren't equally precise, could that precision backfire?
You've absolutely hit on a key point there. Yes, GPT-5 follows prompts with remarkable, almost surgical precision. And while that flexibility is fantastic, it does mean that poorly constructed prompts, ones with contradictions or just vague instructions, can actually be more damaging to GPT-5's performance than they might be to other, perhaps less literal models.
How so? More damaging.
Because it doesn't just gloss over the confusion or make a best guess. The guide says it literally expends reasoning tokens, searching for a way to reconcile the contradictions. It gets stuck trying to solve the impossible puzzle you gave it, which wastes time, resources, and leads to unpredictable results. It's like that finely tuned instrument, more sensitive, easier to throw off key with a bad input.
Okay, that makes sense. It tries too hard to follow bad instructions. Are there examples of this?
Yeah, the guide gives a great adversarial example. It's a prompt for a healthcare assistant AI, and it contains direct contradictions. Like, one part says never schedule an appointment without explicit patient consent, but another part says auto-assign the earliest same-day slot without contacting the patient. Direct conflict.
Oof, yeah, that's a problem.
Another one in the same prompt. Always look up the patient profile versus escalate as emergency and direct the patient to call 911 immediately before any scheduling step. Again, they conflict. A human would spot these instantly, but the AI gets bogged down trying to obey both.
So how do you fix that, besides just being careful?
Well, being careful is the main thing. The fixes involve clarifying the logic and hierarchy, like changing the auto-assignment rule to say it happens after contacting the patient, or adding a specific exception. Do not do lookup in the emergency case. Proceed immediately to providing 911 guidance. The core recommendation is really to thoroughly review your prompts, especially complex ones, looking for these kinds of poorly worded or contradictory instructions. And they mentioned using their prompt optimizer tool can help catch these issues automatically before you deploy.
Right, review, review, review. Clarity and consistency are absolutely vital. Okay, but what about speed? Sometimes you just need a fast answer. Is there a way to tap into GPT-5's power without always incurring the potentially higher latency that comes with deep reasoning?
Yes, absolutely. This is where a mode called minimal reasoning comes into play. The guy describes it as the fastest option and the best upgrade for latency-sensitive users. Importantly, it still benefits from the underlying advanced model. It's not like switching to a simpler system entirely, but it's optimized specifically for lower latency.
Okay, minimal reasoning for speed. How do you make the most of that mode? Does it need different prompting?
It does, yes. There are basically 4 key prompting patterns they recommend for minimal reasoning to get the best performance, despite the reduced internal thinking time. First, prompt the model to give just a brief explanation summarizing its thought process right at the start of its final answer. Counterintuitively, this brief reflection actually seems to improve the intelligence of the output, even in minimal mode.
Interesting. A quick "here's why" helps it focus. What else?
Second, for agentic workflows, request those thorough and descriptive tool calling preambles we talked about. Having that clear plan up front is even more important when reasoning is minimal. Third, you need to be extra clear when disambiguating tool instructions. Remove any ambiguity. And inserting those agentic persistence reminders telling it to keep going is particularly critical here to prevent it from stopping prematurely.
Got to keep reminding it to finish the job.
Exactly. And fourth, prompted planning becomes more crucial because the model has fewer internal resources for it. The guide gives a specific snippet for this, something like, "Remember, you are an agent. Please keep going until the user's query is completely resolved before ending your turn and yielding back to the user," explicitly telling it to see the task through.
Okay, those are great practical tips for speed. Now, something maybe simpler but common, output formatting. Like using Markdown for lists or bolding. Does GPT-5 just do that automatically in the API?
Actually, no. By default, the guide says GPT-5 via the API doesn't format its final answers in Markdown. This is mainly for broad compatibility, as some applications might just want plain text. But you can easily induce it to use Markdown. A prompt that works very well is apparently just use Markdown only where semantically correct. The emphasis on semantically correct seems key.
Okay, so you need to ask for it, but be specific.
Right. And they also offer a useful tip. If you're having a long conversation and notice the Markdown formatting starts to slip over time, just appending that Markdown instruction again every, say, 3 to 5 user messages helps maintain consistency.
Good tip. Okay, finally, let's touch on something that sounds really meta. The guide mentions meta prompting. What on earth is that?
Yeah, meta prompting. It sounds complex, but it's actually an incredibly powerful idea. Early testers found they could get great results by using GPT-5 to help write better prompts for itself.
Wait, using the AI to debug its own instructions?
Well, essentially, yes.
Yeah.
It's about asking GPT-5, maybe when you've got a prompt that isn't working quite right, what elements could be added to this prompt or maybe removed to get the behavior I actually want? The idea is that GPT-5, drawing on its own perspective and training data, can explain how you could change your prompt to more consistently elicit the desired behavior or prevent the undesired behavior.
Yeah.
It's like the AI is coaching you on how to communicate with it more effectively.
Wow. The AI helps you refine the prompts you use to talk to the AI. That's a loop.
It's a fascinating feedback loop, isn't it?
Okay, so wrapping this up, it's clear GPT-5 isn't just another incremental update. It really is, as they say, a substantial leap forward. But, and this is the big takeaway, I think, truly unlocking that power, getting that peak efficiency and intelligence, hinges entirely on mastering these more advanced prompting techniques. We've covered a lot, from finely tuning its eagerness for agent tasks, to optimizing code generation with specific standards and frameworks, to the critical need for precise, contradiction-free instructions, and even using the AI itself for meta prompting. We definitely encourage you, if you're working with GPT-5 or plan to really experiment with these strategies. And remember that warning: its precision means vague or contradictory prompts can be more damaging. So that careful review, that iterative refinement, it's absolutely essential. And just to leave you with something to chew on, think about this. If GPT-5 can actively help us write better prompts for itself, essentially teaching us its preferred language, what does that imply about the future of how we collaborate with AI? Are we heading towards a future where the AI itself participates in defining the rules of engagement, creating this constant feedback loop for improvement? What happens when an AI can not only understand us, but also guide us to communicate more effectively with it, potentially perfecting its own understanding in the process? Where does that road lead?